Lesson 4-2 is talking about matrix addition. The big idea is matrices with the same dimensions can be added in a very natural way. Notice, it says matrices with the same dimensions. Same dimensions are a 3x4 matrix and a 3x4 matrix. Okay? You cannot take, cannot do a 5x6 and a 6x5. You cannot multiply those things together. Okay? They have to have the same dimensions, same number of rows, same number of columns. Okay? Definition of a matrix addition. If two matrices A and B have the same dimensions, their sum, A plus B, is the matrix in which each element is the sum of the corresponding elements in A and B. Okay? So, if I add a 2x2, because I have 2 rows and 2 columns, plus a 2x2, I am going to get out a 2x2. Now I'm going to do it by hand first, but then I'm going to show you how to do it on your calculator. And all you have to do is you have to match up the elements. Okay? So a negative 2 plus 1, you just take the first 1 element plus the 1 element in the next one. So a negative 2 plus 1 is a negative 1. You take the 1, 2 element plus the other 1, 2 element. 5 plus a negative 3. 5 plus a negative 3 is 2. 0 plus 8 is 8. Negative 7 plus negative 2 is a negative 9. So as you can see, a 2x2 and a 2x2 gets you out a 2x2. Can I do this on my calculator? Yes, very quickly. If I hit second function matrix, I'm going to call this A, I'm going to call this B. So they're both 2x2s, so I got to go over to edit here. I hit the number 1, and it's a 2 by 2. Okay? So it goes negative 2, enter, 5, enter, 0, enter, negative 7, enter. Okay? I hit second function quit. Okay? I hit second function matrix because I got to do my B. So I'm going to edit B. So it's a 2 by 2. That goes 1, negative 3, 8, negative 2. Make sure you use your negative signs. Okay? Now, once you got those in there, you hit second function quit. And I got to go back to my name. So I want to take A and I want to add B, as this says right here. Well, if I take A and add B, all I have to do is go to second function matrix. And I leave it on names because I just want the name of the matrix. So I want A, so I press 1, plus, I go to second function matrix, and now I want B, so I press 2. So I have matrix A plus matrix B. I hit enter, and gives me the same answer as I had doing it by hand. Okay? Moving along, definition of scalar multiplication. The scalar product of a real number k
There's an association meeting going on in the music room. Association meeting in the music room. Thank you.
and a matrix A is the matrix K times A, in which the element K times the corresponding element in A. So all this is saying is you're taking K times every single thing in your matrix. So if you look at example 1 here, it says find the scalar product 6 times the matrix. So same thing, the dimension's going to stay the same. Okay? I have a 2 by 2 matrix, so I'm going to get out a 2 by 2 matrix. The only thing that's happening is I'm taking 6 times every single thing in that matrix. So 6 times a negative 2.3 is a negative 13.8. 8 times 6 is 48. 6 times 7.1 is 42.6. And 6 times a half is 3. Okay? All I did was take 6 and multiply it to everything in this matrix. You can kind of think of it as a distributive property. You have to multiply it by everything to itself. Now, can you do it on your calculator? You betcha. I'm going to go to second function matrix, and I'm going to put A in here. So I'm going to take 6. I'm going to take 6 times matrix A, because I'm going to call this A now. This is my new A. So I need to edit A. Press the number 1. It's still a 2 by 2, so I can leave that. But now it is a negative 2.3. Enter. 8. Enter. 7.1. Enter. And 1/2. You can type it in just like the book says. Okay? Now, does it convert it to a decimal? Yes. That's all right. Don't worry about it. Okay? Now I go second function quit. Okay? And all I'm going to do is I'm going to say 6 and then times matrix A. So our calculator will assume if you put it side by side that it's multiplication, so you don't have to say times. All you have to do is say second function matrix, and it's in my A, so I'm going to press the number 1. I hit enter, and we should have got the same thing as we did right here. As you can see, we did. Moving along. Definition of matrix subtraction. This works the same way as the addition. The only difference is now you are subtracting that number instead of adding. So if I have a 2 by 2, I have to subtract a 2 by 2. Okay? It has to be the same dimensions, just like when you're adding. So element 1, 1. Okay? Minus element 1, 1. So 13 minus 8 is 5. A negative 9 minus 6. Well, a negative 9 minus 6 is a negative 15. A negative 21 minus a minus 15. Well, minus a minus is now a plus. So a negative 21 plus 15 is a negative 6. 6 minus 3 is 3. Once again, can you put that on your calculator? Yes, you can. I'm going to call this one B, or I'm going to call this one C. I'm going to call this one D. Okay? So hit second function matrix. I'm going to go over to edit, and I want to edit C, so I'm going to press the number 3. That's going to be a 2 by 2. It goes 13, negative 9, negative 21, and 6. Second quit. Second matrix, I got to put in my D, so I go over to edit, press the number 4. It's a 2 by 2. Goes 8, 6, negative 15, and 3. Go ahead and hit second function quit. Now I'm going to say C minus D on my calculator because that's what I put those in. So second function matrix 3 minus second function matrix D, which is 4, C minus D, hit enter. And as long as you pick your right matrices, you should get out your correct problem. So, will it do it for you? Yes, it will. Example 2 says the matrices P1 and P2 below represent the degrees earned by men and women in 4 professions during 2003-2004. As you can see, we have a 4 by 2. A 4 by 2. Okay? It says create a new matrix that shows the change in the number of degrees awarded from 2003 to 2004 separated by gender. Okay? So technically what we want to do is we want to take 2004 and subtract 2003 because we want to know the difference from 2004 to 2003. Okay? So I'm going to type this in. I'm going to let this be my E. I'm going to have this be E. And I'm going to have this be F. So what I'm going to do this, I got to take F and subtract E. Okay? So let's do that on our calculator. So I'm going to go second function matrix. I'm going to go over to edit. And I'm going to edit 5. And like we said, this is a 4 by 2. 4 by 2. Enter. And this is 8,221, 6813, 2653. And you could be typing these in with me as you go. Just pause it and go at it. Some of you probably typing in a lot faster than me. Okay. Now, I'm going to hit second function quit, second function matrix, and I'm going to edit F, which is number 6. This is also a 4 by 2. Okay. 8273, 7169, 2532, 1803, 2332, 19877, 3511, and 1821. Hit enter. And as I said before, we need to take F and subtract 3 because we want to see which has the create a new matrix. So we created a new matrix. Shows the change in the number of degrees awarded from 2003 to 2004. So we're going to take this and subtract this, separated by gender. So we're still separated. So here's my new matrix here in just a second. Second function quit. And I'm going to say second function matrix, and I want to say F, which is number 6, and I want to subtract second function matrix number 5 and hit enter. So as you can see here, it sets it up the same way. Here's my medicine, here's my dentist, here's my law, here's my theology, here's my males, here's my females. Okay? And it's B says which group, male or female, had the greater total increase in degrees awarded. Well, as you can see, males had 52 plus 416 plus 416 plus 12 gives me 480 minus 121. So that is 359. So males are at 359, and females go 356 plus 112 plus 726. Obviously, the females won, correct, because they had 1,163. So the females had a greater increase in degrees awarded. That's all I have for you today. Please enjoy. I hope that makes sense, putting that into your calculator and making all this work. Have a good day.